The future of warfare just got unveiled on Chinese state television, and it looks nothing like traditional combat. CCTV aired a documentary showing the PLA's roadmap from basic soldier support platforms to something far more disturbing: fully autonomous urban combat units that operate as a coordinated wolf pack, not individual robots following commands. A distributed network with a shared digital brain where each machine plays a specific role in a system designed to hunt. They call them by names. Shadow handles reconnaissance and real-time situational awareness. Polar moves logistics and ammunition across battlefields. And then there is Bloody, a robot dog that walks around carrying an automatic rifle, grenade launcher, and mini-rockets. This is not a concept video. This is operational hardware the Chinese military is actively deploying. The specifications reveal how rapidly military robotics has evolved. These machines hit speeds around 15 km per hour while carrying payloads up to 25 kilograms. The joints are flexible enough to navigate rubble and climb staircases in urban environments. And the control interface has been simplified to an almost absurd degree. A single soldier can command the entire pack using voice commands, a joystick mounted on their rifle, or even gestures through a tactical glove. But what makes this genuinely alarming is a system called ATLS. Chinese engineers trained a swarm of 96 drones and robot dogs to understand each other's intent without constant radio communication. Think about what that means operationally. The network can coordinate attacks even under full signal jamming or GPS denial. The entire system is built to function when classic electronic warfare tools get deployed. When communications get cut, these machines keep operating as a coordinated unit. And the ground systems represent only one layer. At sea, unmanned L-30 boats run at 65 km per hour and can autonomously encircle and ram targets. In the air, laser cannons called Guangjian operate with two distinct functions. One unit blinds entire drone swarms, another burns out electronics on high-priority threats. Algorithms handle the targeting hierarchy automatically. The operator basically gets one button: confirm strike. The decision-making happens at machine speed. Now, the AI capabilities behind all this remain the part China is keeping most quiet about, so treat the coordination claims with appropriate skepticism until someone outside CCTV's edit bay witnesses it live. But the broader military robotics push is clearly not just a China story anymore. Europe is about to conduct one of the toughest real-world field tests for military robots anywhere on the planet. Around 20 international teams are heading into the Swiss Army's Thun training area for LRO 2026. Unmanned ground vehicles and drones will be pushed through reconnaissance, transport, and search and rescue missions in rough natural terrain. And this matters because demonstrating a robot on a polished course is one thing. Dropping it into mud, uneven ground, unpredictable conditions, and realistic mission pressure is something entirely different. No clean urban interiors, no carefully staged environments, just open terrain and military-style tasks where mobility, sensing, autonomy, and reliability all get exposed very quickly. So, while China shows off coordinated robotic combat networks, Europe is essentially building a public stress test for the same broader trend. The common thread is obvious. Military robotics is moving out of theory and into environments where failure actually means something. Meanwhile, something potentially more significant is happening in the civilian sector. AI agents are starting to run humanoid robots directly. A company called Humanoid ran an experiment where cloud-based AI from SAP's platform controlled a wheeled humanoid called HMD-1 Alpha through something called the dual agent layer. The robot received high-level business tasks and executed them autonomously inside a real messy warehouse. It found the right pallets, grabbed boxes, and loaded them onto carts completely on its own. The bigger concept here is that corporate AI software will not just handle purchasing and scheduling, it will also operate physical robots. In the enterprise of the future, your company does not just get a digital brain, it gets working hands to match. Jeff Bezos is betting heavily on exactly that future. He is launching a $100 billion investment fund aimed at buying up industrial companies in aerospace, chip manufacturing, and defense and rebuilding them around AI. As preparation, he has been quietly snapping up AI startups. Amazon just bought a robotic startup called Fauna along with its humanoid called Sprout. This is a compact bipedal robot about a meter tall, designed with a soft shell, no sharp joints, and a focus on social interaction. The pitch is that it is safe enough to learn in human environments. A week earlier, Amazon also picked up the company behind the river delivery robots. Bezos wants to automate last-mile delivery and is not being subtle about it. Leaked documents suggest Amazon is planning to replace up to 600,000 future job openings with AI and robots. While the public messaging stays careful, internally, this looks very much like a long-term workforce substitution play. If you thought robots were coming for jobs in 10 years, the answer is no. They are already in line. BMW, which had been testing Figure's robots, is now running a new humanoid from a Swiss company called Hexagon. The robot is called Aeon, and BMW is testing it at the Leipzig plant on high-voltage battery assembly and complex component production. Aeon is built for precision work over raw lifting. It moves on wheels at about 2.4 meters per second, which works out to almost 9 kilometers per hour. That is several times faster than most walking humanoids. It handles parts up to 15 kilograms and swaps its own battery every 4 hours. The big takeaway is that features that seemed cutting edge a year ago are already becoming baseline requirements. Humanoids are starting to compete for jobs, not just attention. Elon Musk wants to end global dependence on chip suppliers. He just announced that Tesla, SpaceX, and xAI are building a vertical chip fortress in Texas on a site almost 9.5 kilometers across. The idea is a closed ecosystem from raw silicon all the way to finished processors, all under one roof. The ambition is classic Musk, planning to run the 2-nanometer process that the rest of the world is just figuring out. At the scale he is targeting, that would represent about 70% of current global production. His budget estimate is $25 billion. Analysts already put the real number closer to $50 billion. If Musk actually pulls this off, it turns Tesla and xAI into companies that no longer depend on TSMC or anybody else for silicon. That is a level of vertical integration nobody has seriously attempted in the chip industry. But while the fortress remains on paper, Tesla's recent hiring push tells a different story. They just opened a wave of production line job listings specifically for Optimus. The prototype phase looks like it is ending and the factory phase is starting. The internal plan is 50,000 robots this year. The first batches are not going on sale, they are being deployed inside Tesla plants. And now there is another piece that makes that scaling story more interesting. Tesla's China leadership just suggested that Giga Shanghai could become a major enabler for mass humanoid robot production. That matters because one of the biggest bottlenecks in this entire industry is not designing a humanoid that works once. It is manufacturing huge numbers of them reliably and cheaply. Shanghai becomes important because the plant already pushed out around 851,000 vehicles in 2025 and is one of Tesla's most efficient production hubs anywhere in the world. Meanwhile, Chinese scientists just taught a Unitree G1 humanoid to play decent tennis. The breakthrough is not the tennis, it is that they did it without a proper dataset. Normally, training a humanoid on dynamic tasks requires either massive datasets or extensive hand-coded motion. The team skipped both and got the robot playing in 5 hours, using a technique called latent learning. Inside a simulator, the robot experimented with angles, timing, and striking force on the fly. It taught itself to return shots over the net. The final result was about 90% success on forehand returns and close to 80% on backhand. And Unitree clearly is not stopping at tennis. One of the weirder real-world clips making rounds shows a customized Unitree G1 in Poland chasing wild boars through a parking lot and grassy roadside area. The robot, called Edward Wacky, was jogging around trying to herd the animals back toward the forest while people filmed the whole thing. The Boers were not exactly impressed and mostly ignored it. But the point is bigger than the clip itself. This is a humanoid operating in an uncontrolled public setting around animals, people, distractions, and all the usual chaos that makes the real world harder than any lab.